everyone, my name is Karuna Singh and welcome to the channel knowledgestar, continuous knowledge excellence. In this video, we will get to know about the synthesis and characterization of the GCS-g-DEAP Nanogel and Nanogel Morphology. Now, our expert, Professor Himadri B. Bohidar, who is associated with National Center Excellence in Agro Nanotechnology, Delhi Daikin Nanotechnology Center, India. He has 31 years of academic experience in teaching and research. His area of expertise includes nanoscience and nanotechnology, nanobio interface science, soft matter science, polymer physics, biophysics. Will explain you in detail about this topic. So to get complete information, watch full video without skip.
Okay, now after the precursor has been synthesized and characterized, it is required to form the nanogel now. So we take certain amount of this polymer precursor. This is what it is. Dissolve it in DMSO and allow it to equilibrate for a while. And then you put it in the dialysis bag with some molecular weight cutoff of 8,000 and dialyze it against sodium borate buffer solution for about 24 hours. And you continue 2-3 times. Then the lyophilized product is subsequently filtered to another level of purification, freeze dry it, and the powder you obtain is basically nanogel. Now it can be dispersed either in acidic or basic solution, HCl or NaOH, sodium borate buffer solution, a different ionic strength, and then you can have nanogels of different preparations available with you. If you wish to put a drug there, you can load a drug at this level here. Because this is a hydrophobic drug, this will not stay in contact with water, it will enter the hydrophobic core of the nanogel easily, which is basically the core of the nanogel. Now the nanogel size is measured, it gives a typical size about 100 nanometer. Okay, so it qualifies to be called a nanomaterial. This is the morphology, STM morphology. You see typical spherical size of this nanogel we have just synthesized, both at pH 7.4 well defined, but at 6.8 you see it is not that well defined because the nanogel has started in fact disintegrating here because you are in a more acidic condition. So they're tending to now differentiate it and disintegrate it. And all this data is at 37 degrees Celsius, which is close to very physiological temperature. Now, the release of the drug, doxorubicin, which is anti-cancer drug, at different pH, you see here in the in vitro measurements.
Wait. Are you worried about your project, training, dissertation, internship? Don't think too much because Nanoscience and Technology Consortium, in short NSTC, is giving you a golden opportunity to do the same tasks. NSTC also conducts workshops on amazing topics. So if you want to register in the workshop, the registration link is given in the description box below, or you may go to the website www.nanoschool.in where you can easily enroll in the workshops. So just check it out right now.
With time, you see at pH 7.4, the drug release is quite small, cumulative release, 20%, not more than 20%. If you make it more and more acidic, the environment is more acidic, the drug release increases drastically. It has gone almost now to 70%, more than 70% here at pH equal to 7. Pictorially, you see the same thing here because DOX also is a fluorescent molecule. It can be imaged very nicely with a fluorescence microscope. At pH 7, at nanogel, there is no release, hardly any release here. But free DOX you see this everywhere. pH 6.8 from the nanogel, drug is released, this data. And at 6.8, direct application, no nanogel, you see that there is hardly any difference between this and this. So it basically means that the drug release now is regulated when we are delivering it through the nanogel. And we are triggering the release by changing the pH from neutral to the basic. And this is work that is effectively help in targeting the drug to the polymer, to the cancer site. Okay, so The takeaway from the here is pH can be used as a trigger in nanogels. Again, I am reiterating it that we have to choose a polymer precursor which is sensitive to pH change. The nanogel must undergo a either swelling or deswelling mechanism because of the application of the trigger. And in this case, the pH is doing that job perfectly. So whatever we have seen in the last few slides, that we have successfully made a nanogel which can be used for delivery of drugs to the cancer site just by altering the pH, which naturally happens inside the physiological system. And drug delivery at the site or bioavailability of the drug is quite high. So this will increase the therapeutic activity of the drug for the treatment of cancer. This is the hypothesis from this work.
I hope you liked this video. Here I would like to give you an important information that Nanoscience and Technology Consortium organized the nanotechnology workshops on very interesting topics. Also, I would like to tell you about the initiatives of NSTC in which you can also be a part of: mentorship, patent commercialization, joint product development, research projects, consultancy services, nanomaterials for your research projects, training programs or customized training programs, workshops or customized workshops. So that's all. If you want to see these type of informative, educational and interesting videos, then please do comment and subscribe to the channel KnowledgeStar and hit the bell icon to never ever miss an update. Thank you everyone. Thank you so much.
For more updates, subscribe to our channel, click the links shown on the screen to stay connected.